Welcome to the first part of my series on linear equations. Suppose if you had a baby elephant that weighs 700 kilograms and you had a bag of feathers that weighed 700 kilograms. Can you say which of the two weighs the heaviest? If you said none of them, then you were correct. This is because they have the same weight. But what if you had two of the same elephant? How many bags of feathers would you need to have the same weight
as these two elephants?
Got it. You would have needed 2 bags of feathers. Now let's look at a definition for an equation. An equation is a mathematical term or terms or expression or expressions that are equal to some value. It should be noted that equation functions just as a scale. You need to constantly maintain a balance. Here are some examples. If I had 21 equals 21, this statement is true. And to maintain this statement being true, if I were to add 3 on the left hand side, then for it to be true, I must add 3 on the right hand side to maintain the balance. Whatever I do on the left hand side, I must do on the right hand side to maintain the balance. What if I had subtracted 6? If I subtracted 6 on the left hand side, then to maintain the balance, I need to subtract 6 on the right hand side. Similarly, for the multiplication operation, if I multiplied 21 by 3 on the left hand side, to maintain the balance, I need to multiply 21 by 3 on the right hand side for the statement to be true. This also carries for division. For if I had 21 divided by 3 on the left hand side, this would be equivalent to 21 divided by 3 on the right hand side. Let's turn our attention to linear equations. Linear equations have 2 basic characteristics. The first of the 2 characteristics is that all linear equations must have the sum total of the exponents of the variables in each algebraic term being 1. The second of the 2 characteristics is that all linear equations must be able to be represented as a straight line graph. For the purpose of this exercise, we'll be looking at the first of the 2 characteristics. Suppose if we had 7x plus 8 equals 29, then the algebraic term here is 7x. If we were to look at the variable x, x is written to the power of 1, and because it is written to the power of 1, then we can say that this equation 7x plus 8 equals 29 is an example of a linear equation. Here's another example. Suppose if I had 3x plus 2y equals 5. Here the algebraic terms would be 3x and 2y, but the variable x is written to the power of 1 and the variable y is also written to the power of 1. This means that the equation 3x plus 2y equals 5 is also an example of a linear equation. What if I had 3x plus y minus 2z? Here we have 3 algebraic terms, 3x, y, and minus 2z. However, x is written to the power of 1 y is written to the power of 1 and z is written to the power of 1. This means, therefore, that the equation 3x plus y minus 2z equals 12 is also an example of a linear equation. Here are some non-examples. Suppose if I had 7x squared plus 3 equals 10. The algebraic term here is 7x squared. But the x is squared. It's written to a power that is not 1. And because of that, this equation 7x squared plus 3 equals 10 is not an example of a linear equation. Examining the equation xy plus 2 equals 7. When we look at the term xy, we will see x is written to the power of 1 and y is written to the power of 1. In this particular case, xy is one term. So if I were to add the powers together, we would have 1 plus 1 equals 2. And recall, the characteristics of a linear equation is that the sum total of the exponents of the variables in each algebraic term must be 1. And because it is not 1, we can say xy plus 2 equals 7 is not an example of a linear equation. The same argument follows this equation. For x plus xy equals 14 is a non-example of a linear equation. To translate words into equations, you may need to review the last video on converting worded statements to algebraic expressions. Suppose you were given this situation and you were asked to translate this into an equation. Then, the first thing you would have done is to do a variable assignment. Here, x is used to represent the unknown number of marbles. The second stage is to obtain the expression that relates to the information. This can be reviewed in the last video as mentioned before. The first thing you need to do, however, is to locate the keywords or phrases. Then you are going to combine the variables with the keywords to obtain the expression, like this. So that after giving Harry 3 marbles, Tom now has x minus 3 marbles. The third stage is to consider the equality. This means you are going to look and see what all of these information is equal to. And this is equal to 17. The fourth stage would be to combine steps 1 to 3 so that the expression we obtained in step 2 would be now equivalent to 17, so that we would have x minus 3 equals 17 as the required equation. We are now going to look at solving linear equations using algebra tiles. Suppose if we had 3x plus 5 equals 17. Then the first thing we are going to do, we are going to model the equation. 3x is represented by 3 rectangular blue tiles. Plus 5 is represented by 5 yellow square tiles. And that is equivalent to 17 of the yellow square tiles. The objective in finding the solution to a linear equation is to isolate x or keep x all by itself. To do that, what we need to do is to get rid of the positive 5 on the left hand side. How do we do that? We can do that by nullifying this positive 5. This nullification would take the form of 5 rectangular red tiles. This is because when we have the yellow tile and the red tile coming together, we have a nullifying effect, or it is equivalent to 0, so that we see 1 minus 1 is 0. But remember, we said equation functions like a scale. Whatever we do on the left hand side, we must also do on the right hand side. So because we nullified this 5 on the left hand side, we have to put 5 of the red square tiles on the right hand side, like this. This would give you this effect, so that we will have these 3x tiles being equal to 12 yellow tiles. But how can we find what one tile is equal to? What we do a simple arrangement into groups of 3, like this. Now we have 3 groups, so that we can see each group has the same amount of tiles. Now we can conclude that x is equal to 4, because one of the x tiles is equivalent to 4 of the unit tiles. To solve linear equation, you need to recall the laws and properties of numbers, and you need to also recall that all equations function like a scale. For example, if I had 3x plus 5 equals 17, the first thing I'm going to do, I am going to get rid of the 5 by using the additive inverse of 5, so that I would have 3x plus 5 minus 5 is equal to 17 minus 5. This is so because whatever you do on the left hand side, you must do on the right hand side. So if I used the additive inverse of negative 5 on the left hand side, I would have to use the additive inverse of minus 5 on the right hand side. This would imply we have 3x plus 0 equals 12. But recall, 0 is the additive identity, so that this would give me 3x equals 12. Remember, 3x means 3 multiplied by x, so that to isolate x, we need to use the multiplicative inverse, so that we would have 3x divided by 3 is equal to 12 divided by 3. Recall, if I divide by 3 on the left hand side, to maintain the balance, I need to divide by 3 on the right hand side. Then the 3 would cancel with 3, and 12 divided by 3 is 4, so that x would be equal to 4. Here's another example. Suppose if you had this situation where x appears on both sides of the equation. The first thing I can do, I can get rid of the minus 1. And to get rid of minus 1, I need to add 1. This is the additive inverse. And if I add 1 on the left hand side, I need to add 1 on the right hand side, so that we would have 4x minus 1 plus 1 is equal to 2x plus 17 plus 1. This is equivalent to 4x plus 0 equals 2x plus 18. Recall, 0 is the additive identity. The next stage would be to get all the x's on one side of the equation. Usually, we take the x's and put x's on the left hand side. So to get rid of 2x, we need to use the additive inverse of 2x. This means that we are going to minus 2x on both sides of the equation, so that we would have 4x minus 2x is equal to 2x minus 2x plus 18. Again, recall we need to balance the equation, so if I minus 2x on the left hand side, I must minus 2x on the right hand side. This would give me 2x equals 18, because 4x minus 2x would give me 2x, and 2x minus 2x is 0, and 0 plus 18 is 18. Now that we have 2x equals to 18, we can find the value of x by using the multiplicative inverse, so that we would have 2x divided by 2 is equal to 18 divided by 2. 2 divided by 2 is 1, 18 divided by 2 is 9, and so therefore your answer will be 9. X will be equal to 9. Thanks for viewing this video. Please don't forget to hit that like and subscribe button. See you in the next video.